Welcome back to the 8-2.3 page. We started the notes in video 1. We looked at the graphing calculator investigation. In the second video, we looked at what happens when you have an exponent of 0. And we determined that whatever you're raising to a power of 0 is going to end up being equal to 1. So if you raise it to a power of 0, you end up with 1. Now, in this third video, we're going to look at what happens when we have a negative exponent. So we are going to take a look at this expression, 8 to the second power divided by 8 to the fifth power. And we're going to look at two methods. So here's method 1, if I can get it to go. So in this one, they are using that quotient power. So when you have the same base of a power and you are dividing them, you keep the base, so keep the 8, and then you subtract your exponent. So 2 minus 5, and when you do that, 2 minus 5 gives you negative 3. So they're saying that this 8 squared over 8 to the fifth is going to be equal to 8 to the negative third power. All right, so that's the first method. In the second method, take a look. They're going to be using the definition of powers, meaning they've got 8 squared, so they're showing it as 2 factors of 8, so 8 and 8. And on the bottom, they're showing it as 5 factors of 8. Just like what we've been doing, we know that if something is occurring on the top of a fraction and on the bottom, those things can be canceled if they're the same. So we cancel 8 here, 8 there, cancel 8 here, 8 there. And what happens is we're left with nothing on top, so we have to represent that as a 1. And then we have 8 times 8 times 8, or 8 to the third on the bottom. So in this method, they're saying that 8 squared over 8 to the fifth is actually equal to 1 over 8 to the third. All right, let's take a look, because now we're having two different things being said. So this one said that it was equal to 8 to the negative third power. This one said that it was equal to 1 over 8 to the third power. Now, since we can't have two different values, we're going to conclude that this 8 to the negative 3 is equal to 1 over 8 to the third. So you'll notice is that we're taking this number here. So if you think of just 8 as a whole number, if you were to make it a fraction and put it over 1, that's what it would look like. So all we're doing is taking this fraction and flipping it upside down and then changing the exponent to the positive version of itself. So for any non-zero number a and any integer n, a to the negative n is the reciprocal of a to the n. In addition, the reciprocal of a to the negative n is a to the n. Now, this is a whole lot of math words that probably don't make a whole lot of sense. And even when we get to the symbols, this might not make a whole lot of sense. But hopefully, when we get to the example part, you'll be like, oh, well, it goes like that? Easy. So right now, I've got for any non-zero number a and any integer n, I'm going to write this. If we have a to the negative n power, it's going to be equal to, we're going to put 1 and then a goes to the bottom and the exponent switches from a negative to a positive. So it's going to look like that. And then the other way that we might have it is that if we have 1 over a to the negative n like this is just going to flip it the other way. So a to the n is going to go to the top, and the exponent becomes positive. And you could write it over 1, but we usually just write it like that. So we're taking whatever the base is and its negative exponent, and we're pushing it either to wherever the opposite is. So if it's starting in the top, it gets pushed to the bottom. If it's starting in the bottom, it gets pushed to the top. So looking at some examples here, if we have 5 to the negative 2 power, this is going to, if you think about it as like being over 1, we would end up switching the fraction 1 to the fifth, and then we just have to make sure that we keep that exponent with it and turn it positive. All right. For another example, so I'm just going to put a break there. If we start with 1 over m to the negative third power, we're just sending the m to the top because it has a negative exponent. So it gets sent to the top. We switch the exponent to a positive, so it's m to the third. And technically, we flipped our fraction, but we could just write this as m to the third. So it's kind of crazy. And it's going to get a little bit more crazy with these example problems that we have here. So in the example problems, I'm going to change my pen color. We have a b to the negative third, we have a c squared, and we have a d to the negative fifth. Now we don't have any like terms here, so we can't do any simplifying to begin. But what we can do is we want to switch, like if they're starting in the top with a negative exponent, we're going to push them to the bottom. So this b to the negative 1/3 is really 1 over b to the third. So I'm rewriting it so that it is, it now has a positive exponent. Now the blue piece, c to the second, that c is raised to a positive power, so it doesn't change at all. It's just c to the second. And if we wanted to, we could put it over 1. And then finally, so that was, sorry, that's the blue. And then finally we have this d to the negative fifth, which is on the bottom. So to make the exponent be positive, we can push the d to the top, so it's d to the fifth over 1. So I just took it from being on the bottom with a negative exponent, pushed it to the top, and gave it a positive exponent. So that's this piece. Once you have everything kind of switched up and down so that it's in the correct place, then you're just rewriting. So we've got 1 times c squared times d to the fifth. All that's going to be is c squared d to the fifth. On the bottom, we have b to the third times 1 times 1. Those ones don't matter. We just have a b to the third. So here's our answer. We have c squared d to the fifth over b to the third. So that is example A. All right, in example B, hoping to get this done in 3 minutes. We've got numbers here, so negative 3 over 21. We've got a to the negative fourth, a squared. We've got b to the seventh, b to the seventh, and then finally c to the negative fifth. So what we're going to do is we're going to first simplify those numbers. So I've got negative 3 over 21. For me, I'm going to go to my calculator and plug that in. So I've got negative 3 divided by 21, enter. I get this weird decimal. Decimals are not our friends, so we turn it into a fraction, and it comes out to be negative 1/7. So I'm going to start with that. So the yellow piece was negative 1/7. Now with this, with the blue on top and the blue on bottom, like before when we were doing examples, it was easy to kind of to simplify and to cancel things out, but because they're negatives and positives, it gets kind of weird and confusing. So we're going to use our quotient rule. Remember that states if you have the same base and you are dividing the powers, then all you have to do to come up with your exponent is subtract. So we're going to keep our a, and we have negative 4 minus 2. Negative 4 minus 2 is going to be negative 6. And then for our b, we keep the base of b. 7 minus 7 is 0. And then we have our c to the negative fifth on the bottom. Now, with that, we can, because it's a negative exponent, we can push it to the top and give it that positive exponent. So this right here, like, I know you're feeling like, oh my gosh, we've got to be done. Like, we have to be. But we can't have an answer with a negative exponent in it. So what I'm going to do is I'm going to push that to the bottom. So we've got a negative 1 on the top. This is crazy. So this, we're going to treat all of these like they're over 1, just so that it makes it a little bit easier. We've got negative 1 over 7. This a to the negative 6th is going to turn into 1 over a to the positive 6th. So we're pushing it to the bottom and changing the exponent to a positive. B to the 0 comes out to be 1, which could be 1 over 1. And then we still have this c to the 5th. Once you get everything here, you're just combining. So 1 times 1 times 1 times c to the 5th is going to be c to the 5th. 7 times a to the 6th on the bottom is just 7a to the 6th. Here's our answer in simplest form.